We're looking at the Unit 2 test review, and I'm just going to briefly go over things that are similar to stuff on your test. And the first two questions are just talking about equations that have equal signs and inequalities that are greater than, less than, greater than or equal to, less than or equal to, like those are the inequalities, just saying that one part of an equation is larger in value than the other side of the equation. So you've got a couple of questions about vocabulary, and you can always look back at your lessons for that. You also are being asked about setting equations equal to 0. So there is a strategy that Buzz has used where you take an equation and you set it equal to 0 before you're able to set it equal to each other. So I'm just going to do like an example with some random numbers here. So when you set it equal to 0, what you have to do is you have to get everything over to one side so that you have room to put a 0 here. So that means I need to move that over. I need to say plus 7 plus 7. And that's going to be x plus 16 is greater than 0. So I'm setting that equal to 0. And I need to do the same thing with this side. I need to get this side ready to set equal to 0. So I need to have a 0 on this side. I do it to one side. I do it to the other. Y minus 16 is less than 0. So that is why I have, this setup is so that I could set them greater than or less than each other. So the whole point of the 0 strategy is to take those inequalities and set them equal to 0 so that you could set them equal to each other. So that was a part of, what we did in our stuff. So that was just one strategy, and then you would actually just solve for x or solve for y at that point. Okay, moving forward, we've got some equations that are in standard form, which means ax plus by equals c. They're given to us in this format. And here's my example, 12x plus 3y equals 24. And what you're supposed to be able to do is simply put this into slope-intercept form. So this is just Algebra 1, again, appearing here. And slope-intercept form is just y equals mx plus b. And I know you remember that because we did it so much. Your m is your slope and your b is your y-intercept. So basically all you're doing in this kind of problem is you're just isolating y, and you're getting y by itself. So in order to do that, I need to move everything over to the other side. And I do it by doing the opposite. It's positive 12x now. I'm going to say negative 12x, negative 12x. Well, I cannot combine those because one has an x and one does not. So I'm just going to leave them separately sitting there on the line because one has a variable and one does not. And I'm almost there now, but I still have a 3. So I've got to get rid of that. And that 3 is multiplying to the y, so I have to divide by it to get rid of it. And I do it as well to each thing on the other side. So in order to do that, I just divide and simplify. Negative 12 divided by 3 is negative 4x plus 8. So now I have it in my slope-intercept form. So then it'll ask you questions like, what is your slope? What is your y-intercept? Well, we know that our slope is m and our y-intercept is b. So those are pretty straightforward, easy questions. Then you move on into what we called piecewise functions. And I have a whole video on each of these things. But the piecewise functions are where you take, I hope that I'm spelling this right. I am, good. Piecewise. And that's where you have pieces of a graph that you are looking at different ranges. So, for instance, if I have a graph that looks like this. I have an open circle here at this area, and it's a parabola, and it just goes to here with a closed circle. And then I have a straight line to here with a closed circle. And then I have, another line that goes here, and I have an arrow. This could be my piecewise function. So what you're looking at on your piecewise function is the first part of your questions on your test is just looking for where is it. So where is this section of your function? It's going to be an x squared. It's going to be an x plus 4 squared plus 2 function, because it's a parabola and it's shifted 4 to the left and it is up 2. But what you're looking at is the range of the domain of where you see that. So you see it along the x between what? It goes from 1, 2, 3, 4, 5. It goes from -5, and it stops at -3. But since this circle is open, -5 is still the smallest part, but it never actually achieves 5 because it's an open circle. But at -3, sorry about that. Let me erase that. At -3, it actually has a closed circle, so that's why it has the equal sign underneath. So then the next line is, it's cutting through the y-axis, so it's going to be y equals 3, right? This is at y equals 3. But you're only seeing it between these sections, between -3 and +3, right? Along the x. It's only taking up that much space. But they are both closed circles, so this is what your the piece that you're seeing. So then this one, whatever the equation is for that line, you're seeing that from 3 to infinity as far as going to the right or left. Yes, it looks like it's going down to -infinity, but that's for the range. That's for going up and down. We're looking at the x, which is domain, which is right and left. So we're checking to the right. So it's going to infinity to the right forever because it's got an arrow on there, and it's also going to the right. So we are including the 3 because this circle is filled in, and infinity never has an equal underneath it. So you have to really look at your range your domain on a piecewise function. So that's what it's talking to you about on that. So number 7 type of question is just giving you a simple equation. I'm going to give you one similar. And what I'm going to show you is, if this is just a plain old ax plus by is greater than c equation, you just have to determine which graph it is and where it's shaded. So I'm just going to put this into y equals mx plus b so I can even see what it looks like. So I'm going to move over my x minus x minus x. So I'm going to say 4y is greater than -x plus 10. And I'm going to look at getting my y by itself by dividing by whatever's in front of it. So here's my equation. Y is greater than -1/4 x plus 10 over 4. Well, I could divide those both by 2, right? So I could say 5/2. And when I look at this on a graph, for some reason, I'm having a hard time erasing. When I look at this on a graph, what I'm going to do is I'm going to graph my line. I'm going to go to 2.5, my b, splat, and I'm going to go down 1 to the right 4. down 1, right 1, 2, 3, 4. So here is my next point, okay? This is a greater than sign, but it doesn't have an equal with it. So I'm going to make sure that it is dotted. And now here is the telling tale. I have to say y is greater than all of that, all of this. So I'm going to say if y is greater, where does this cross the y? Right here. So if y is greater at that point, it's going to be up here. So then I'm going to have to make sure that I have shaded that. Now, could you put this into Desmos to see what the equation looks like? Yes, but I don't believe that you're able to see the shading. So I just wanted to talk to you, about that shading on number 7. Okay, so then as you keep going through your test, it's just checking, do you know what things are? Sometimes it gives you vocabulary work. But then it talks about, since this chapter was so long and so full of stuff, we're looking at the inverse of different functions. And the inverse is very easy. It's where you take your function and you just switch your x and y. So I'm going to say 3x plus 7. So if this is my equation, which you have different equations in your test, but this is a similar. All you do is you change your x and y. Since f of x is always y, I'm going to say x equals 3y plus 7. Do you see that all I did was I just changed my x and y? And now I'm going to solve for y. That is all I do for inverses. And that's also what I do to check it, to see. So I'm going to move everything away from the y. I'm going to move the 7 over. So I've got 3y equals x minus 7. Can't combine them because they're different. Divide by 3, divide by 3, divide by 3. There you go. So I could say y is equal to x over 3, or 1/3 x, minus 7 over 3. Or it might look like y equals x minus 7 all over 3. It just depends on how the author of the test is writing it. They are actually identical to each other. It doesn't matter which format you use. So that's important. So then on number 10, what you're doing is you're doing the same thing. You're just checking to see if the second equation is the inverse. So you're going to take your equation, switch your x and y, and work it out and see, yes or no. And then you keep going into number 11 is vocabulary. Number 12 is where you are doing Gaussian elimination. And that is not hard. It seems hard, but it is not hard. I'm going to give you an example. I hope that the example that I'm making up here in my head is a good example that works well, but I am just making it up to remind you how to do it. I'm going to say x plus 3y equals 8, and I'm going to say 2x plus 6y equals 4. Let's just say that. Okay, so I'm making this up. And what I have to do is I have to find the values of the x and y. So the first thing I'm going to do is see, well, what do I want to cancel out? Remember, I have to have a positive and a negative of each x or each y. So I think I'm going to take this 3 and 6 right here, and I think I'm going to try to make this be a negative 6. Because negative 6 and positive 6 would cancel out. So in order for me to do that, I have to multiply the whole thing 3 times what gives me negative 6? Negative 2. Because 3 times negative 2 is negative 6. So now I'm going to distribute that to every single thing and rewrite my equation. Negative 2 times x. Negative 2 times 3 is negative 6y. And negative 2 times 8 is negative 16. But I'm just going to keep this one and rewrite it because it's already, oh my goodness, look what happened on mine. Let me change this. I'm so sorry. So sorry. I put a number I shouldn't have put on there. I didn't realize it would have no solution because I just made it up in my mind. Okay, so I'm just leaving this equation as it is. So now what I'm able to do is I'm able to cancel these out, aren't I? I'm able to -6 and +6 cancels. So now I've got 3 minus 2 is 1 equals -12. So now I already have that my x is -12, don't I? So since I have one, let me just pick one of these equations like this one, the first one. I'll say x plus 3y equals 8. All I have to do now that I have a variable is I can just plug it in. And I can say -12 plus 3y equals 8. So let's just now solve for y. We're just going to say plus 12, move it over, right? That's gone. 3y equals 20. Divide by 3, y equals 20 over 3. So my answer is -12, 20 over 3. That's my solution set. So that's what my x equals, and that's what my y equals. Okay, I'm not really going through the vocabulary because that's so easy to look back at. But what I am going to do as the very last thing is absolute value. So we spent a lot of time on absolute value. We know that this is our Willy Wonka chocolate machine. Anything that's in here is going to come out positive because any ingredients we put into our Willy Wonka chocolate machine is going to come out positive. And what we're going to do is we're going to talk about how to get the possible answers that could be your x. Because whatever is inside of here could become 12 as a negative, or it could become 12 as a positive. So there's two different answers that x could be in order to do that. So we're just going to take our equation and split it into two different ways. So all we do on absolute value is we take it and we say x plus 5 equals 12. And then we do the other possibility to see what would make the -12. And we're going to say x plus 5 equals -12. So whatever our x is in each situation is the two possible x's that would make this either be 12 or -12. So then I just simply solve for x. X could equal 7. Or x could equal -17. So these are the two possible answers for our absolute value. And then make sure, guys, that you show handwritten work. You check the slides that we sent. And because, listen, they're like 275 points apiece. You really do need to make sure that you include all of the written work for each of those questions. So I hope this has helped you. Good luck for your test, kids.